So hello everybody, my name is Anthony Downs and I'm one of the principal consultants at Wamboin Partners. We're a company that helps heavy industry, gas, oil and miners understand emerging technology and help them understand what it does, how ready it is for them to use and how they can get value out of it. So today I'm going to talk about some work we did with one of the tier 1 miners around tele-remote operated equipment and how we're looking to use VR to make them safer and more productive using that equipment. As I go through this morning, we'll talk about the importance of firmly understanding the current state and understanding how VR can add value. So you don't want VR to be something on top, you want to embed VR into the way the work is done. Secondly, we're going to talk about the importance of getting a prototype out there quickly. So don't talk to people with slides, don't talk to people about concepts, mock something up even if it's quick to actually get them to start to understand what you're doing, and importantly engage with a diverse subset of users as you go through validating the approach and the design. So don't just talk to one person, just don't talk to two, talk to a whole range of people, because you'll find everybody you talk to will give you another gem, another little bit of information that no one else had told you before. So a little bit of context around mining. So mining is not a safe activity. There are a lot of controls we have in place to either mitigate or contain things when they go wrong. But in the mining industry, across every miner every day, there are high potential incidents happening. And what we try to do is put controls in place using this hierarchy of controls. So down the bottom basically is you give someone some safety glasses and a hard hat. Okay, that's the least effective control, but is better than nothing. And you kind of work your way up by having kind of standard ways of working, and then you look at isolating people from the danger, then you substitute, and then you eliminate. What we're doing, and what you'll see later on in the presentation, is we're actually taking people out of hazardous situations and putting machines into those hazardous situations. Okay. So this particular use case, this mining company had to deconstruct tailings dams. So tailings dams contain the waste after the mining process has been completed. So it has a lot of mud, a lot of material, a lot of chemicals in it. These tailings dams, in these ones in particular, were at risk of failing, at risk of breaking and flooding material out of those dams. And so the organisation had to deconstruct those dams very carefully before they collapsed. And because of the risk, we couldn't put people anywhere near them. They were not stable enough to be even close to. So we had a whole range of different equipment, bulldozers, graders, trucks, excavators, and we started off with 30 of them, but we're on a pathway to get more than 150 of these operating continuously in 2 10-hour shifts, 6 days a week. And you can see, I don't know how clearly you can see, but on the top of that truck there, you can see some antennas and some cameras right above the cab there. So each piece of equipment has 7 cameras on it that basically bring back live vision to our control room. So this control room is about 100 miles away from where the actual equipment is. And you can see on the top, the gentleman there is driving a truck, and on the bottom, he's driving a bulldozer. And so you've got those 7 cameras. So you've kind of got a camera looking straight ahead, you've got some cameras looking out to the side, you've got some cameras looking out the back, and then there's an overall camera giving you the understanding of where you are compared to the other equipment in operations. What we did initially is we said to be able to operate this equipment remotely, you had to have operated it in cabin for at least 10 years. we think we may have made an error there, and we're doing some A/B testing. We think actually getting someone who's never driven that piece of equipment before, putting them in the seat and teaching them how to play the video game may actually get us a better outcome than someone trying to reverse engineer what they've learnt by physically sitting in the machine to trying to run it basically from an office building. We also found that if you take the same operator, the same equipment, and give them the same job, the difference between them operating it from within the cabin versus from operating it within the office building is, with a good operator, you're going to lose 20% productivity as soon as you take them out of that piece of equipment physically. If you have an average operator, you're going to lose another 10%. So you're going to lose 30% productivity. And remember, in this particular use cases, these dams are on the verge of collapsing. We want to get them decommissioned as quickly as possible. So losing 30% productivity isn't a great place to be. We also find that the operators, when operating remotely, cause more wear and tear on the equipment compared to if they're actually sitting in the cabin. And we also find the buddy effect. So if we go back, you can see on the bottom there's a colleague, a meter away, and these are very large. Kind of think of a call center, but instead of taking phone calls, they're operating equipment. When you're physically sitting in a bulldozer or a truck or an excavator, you're kind of in a bubble. You have a radio, but everyone knows the boss is listening on the radio, so the chatter's kept down. But when you've got all these colleagues side by side, it's not hard for the conversation to turn to football. It's not hard for the conversation to turn to the barbecue on the weekend. And so you've also got that distraction element happening as well. So we can't have people in the cabins of the equipment because the situation is too dangerous for them to be physically there. So we've needed to leave the equipment there, bring the operators remote. As soon as we do that, we start to lose productivity. And we started to think about, okay, so why is this happening? And there's a couple of key things. We give them 7 cameras and we give them 3 computer monitors. The issue is when you're physically in the equipment, you look left and you see what's on your left. You look right, you see what's on your right. You look up, you see the rear vision mirror. Trying to reconstruct that with windows on a computer monitor is unnatural, and it really changes the way the operators perceive what's going on. They've got headsets that you would have seen, but that's for the radio channels. They're not hearing the engine, then they're not hearing the material scrape on the bottom of the bulldozer. They're not getting that audio come through. And finally, they've got joysticks, but those joysticks are free-flowing. They're not feeling any resistance. They're not feeling any vibration on those controls. And then we've also got the focusing. Their mates are sitting each side of them, probably talking about something more interesting than what they're doing, driving the bulldozer. And so we set about how do we address each of those to make the remote operation of the equipment closer to what it would be if you're physically sitting in the equipment. And so we kind of talked to a whole range of people, and we figured that the thing that's going to get us the biggest return on investment would be to look at how do we give them better situational awareness visually. And so what we've got there is a pair of DJI goggles that we kind of cracked open and hacked apart a little bit. And this bench test, you'll see that there's a camera sitting on a gimbal there. And basically, we rigged it up so when you turn the goggles left, right, up, and down, the camera will mimic you, right? So when you turn left, the camera turns left, turns right. And so what we're able to do is get an operator to wear those, and they would operate the equipment just like they were in it. And as they were looking around like normal, the camera would give them that vision. And it worked okay. There were 2 issues. The lag between you turning your head and the camera turning from a mechanical camera, particularly with that length, had some lag in there. It was workable, but not great. We also found that these operators work a 5-hour shift. They have an hour for lunch. They work a 5-hour shift. And then they go home and another group comes in and they work 6 days a week. So they're doing 10 hours a day, 6 days a week. Wearing the DJI goggles for 5 hours straight is not a very comfortable or proposition, and we're really getting some very strong pushback that this isn't the right device. They love the idea of getting better visuals of what was going on, but they said that the headset was going to be the no-go for them. So we kind of pulled that apart into phases, and then we came back with the second generation. And the second generation, we said, let's not have a mechanical camera trying to mimic the head movement in the truck. Let's go for a fixed camera. Let's bring the 180 degrees back, and then let's actually just pivot the image in the headset as the person moves their head. Okay, so you're removing that lag from needing to mechanically move the camera. Importantly, we were originally bringing back 7 high-definition streams off each piece of equipment. On a typical site where we were decommissioning these dams, we had 30 or so pieces of equipment. So a lot of material coming down the fiber, and then we're trying to push real-time control back the other direction. By going with these particular cameras, we ended up with 1 camera instead of 7 cameras that we're having to stream back. So where are we now, and what is my ask to you guys? So there's a couple of things. I'd love to find a headset that's going to work, where I'm going to be able to encourage 150 operators to wear 5 hours a day, 6 days a week. It's got to be light enough. It's got to have airflow and comfortable enough. And I'm confident someone's got something out there. But if you look at the kind of the consumer grade devices that you would have seen up on the shop floor, I'm not sure any of them are there to kind of meet this use case. We're also, there's the first spelling mistake for the presentation. We're also looking to bring in, being able to see the levers, so being able to see the control board, and even overlaying some telemetry like engine revs, fuel loads, other data that you would normally see on the keyboard. Sorry, normally see on the dashboard of the equipment. And we're keen to talk to people who maybe have that concept of being able to overlay real-time telemetry on real-time video in a very much a bandwidth-constrained space. Also, I just want to kind of put this out there. This is a company that I'm aware of. We haven't done work with them, but I'm really excited about what they're doing. It's a company based in Salt Lake City, and they're basically looking at removing the need for people to work at heights. So this sky lift here, I don't know if people have worked with them in the past. There's many fatalities caused by people falling out of these, by these falling over, by people wearing harnesses incorrectly and kind of falling out of the harnesses as the harness tries to save them. And so this whole concept is very similar to what we're doing with the tele-remote equipment, is don't put people in a hazardous situation, put in a piece of equipment in a hazardous situation, and put the person in a safe location. And so this is a piece of equipment that can basically have a whole heap of different tools attached. So it could be a painting, it could be an angle grinder, it could be a welder. And basically you've got the person standing on the ground wearing VR goggles with the handsets. You've got cameras up on the piece of equipment, and the operator's doing what they would normally do, but they're standing safely on the ground. Okay, so I think you'll see in industry more and more of using VR, not just for training or not just for design, but actually using it to do real-time, real work out into the field. And again, if you look at the welding or the angle grinding, these are jobs that would generally take a day. So again, you're going to be looking for that person there to be able to have those goggles on for a number of hours while they're doing that task, have a break, come back, put the goggles on and continue. So again, I think that need for, fit for purpose long-term wear is something that's only going to continue to grow. Also want to point out what we're doing in the mining industry today is very similar to what I imagine people are going to be doing on the moon, going to be doing on Mars, going to be doing on satellites or asteroids, etc. in the future. The concept that it's either too far, too dangerous, too costly to get a person there, and then to kind of swap the person in, swap the person out to keep the equipment running. The remote control concept is going to continue to grow and grow. And the work that we're doing, we really want to kind of call out to people who are thinking about Mars, moons, asteroids. If you've got the idea and you want to try it in an environment that's going to be harsh, it's going to be abrasive, the mining industry is a great place to come and try that. Okay, so we want to be a test bed. We want to be an early adopter to help people, perfect solutions that potentially they're going to look to use off Earth as well. So the key takeaways, we have been as successful as we have today because we embedded ourselves in the operation. We understood their pain points. We understood what was working well, what wasn't working well. We got prototypes out there quickly. We got feedback, this worked, it didn't work, this isn't going to work. I can't believe you're asking us to do this feedback as quickly as possible. And we asked lots of people because you may end up finding somebody who absolutely loves it and the other 99 who you didn't ask absolutely hate it. And so you've got to make sure that you've got a diverse range. So you've got the bosses, you've got the supervision, you've got the workers, you've got the maintainers. You're going wide to try to get that feedback as quickly as you can so that you can understand what you're doing, whether what you're doing is adding value or subtracting value to that person's day-to-day work. Then my contact details, if anyone wants to reach out, if anyone's got ideas, super keen to collaborate. As I said, I think mining's a really great test bed, so if you've got ideas, you want to try them in real life somewhere, we can certainly help make that happen as well. Thank you.
Great presentation. My name is Lance Benoit with ACO. I'm curious, throughout your project, did you guys track or do you have data to show if you had any vehicle incidents or increased damage to your equipment because your operators were remote?
Yeah, so particularly in the early days, we did have some kind of low-speed interaction. So the whole space perception of, how big is this gap? Can I get through this gap with my machine? In the early days, that perception wasn't quite there. The positive thing is, you end up kind of positive. You end up having machine damage rather than damaging anyone in particular because there's no one there. But yeah, we actually have super good data because we've got all those video streams flowing in, we've got all the telemetry flowing in. We've actually got more data than you normally have in an operation to understand what's going on, what was the cause, how did that come to be. Yeah.
Anyone else? We can take one from the app or anyone else. Up, perfect.
So I'm just kind of curious as an alternative idea, mostly because I'm fairly certain you've considered it but didn't hear about it. But what about using something like a, multiple rear projection screen cave system or something like that to surround the user in the 180-degree experience as opposed to a headset?
Yeah, we definitely looked at the cave concept. There were a couple of things against it. So when we end up with 150 people on shift, we've got issues with size, so that the caves take up room, and then also the cost. So the headsets aren't cheap, but they're certainly cheaper than building 150 caves to operate daily. So we saw that. We saw the headsets as a more likely to get the business case over the line than the caves would be. Yeah. Thank you.
And that does it for today's presentations. Lunch is being served in the exhibit room, and before everyone goes,